Hi, welcome to part 4 of Hypertables. This is the final part in the 4-part series on implementing hypertables. So let's talk in this part about some more granular things that you don't typically see in the documentation or talk about with other people when implementing hypertables. First, as far as data types, you want to use timestamp with a time zone data type for timestamp fields when you partition by time. You want to use text instead of varchar for text fields for faster compression. And for any range partitioning, which again, we don't typically recommend, but if you do range partitioning on a non-timestamp field, a device ID, for example, you should use an integer data type. And then you also want to ensure that any unique index or primary key includes the partitioning column, and that will maintain uniqueness across all partitions. And for unique indexes, for the create unique index command, that's actually enforced. If you do not have that partitioning column, it will actually error and not form the index. So also, some other things to keep in mind when you're going through the initial setup of your hypertable and you are populating it with either an existing Postgres table or streaming data in, you want to avoid using migrate true when you first set it up. You want to start with an empty hypertable and load data into that preferably. And the reason for that is because many times that command, because it's doing partitioning in the background, will take a long time. So you're better off and you're more stable if you just create the hypertable conversion up front and then load data into it. And then also keep in mind, when you load or insert large data sets, for example, when you load latest data or you backfill, you want to try to ensure that the data is sequentially based on partition key so that the data is written to a single chunk at a time. And that goes back to what we talked about a little bit in part 3, memory caching. If you can ensure that the chunk is always memory cached, you're going to get faster writes and reads from it. So by doing so into a singular chunk, you ensure that it's cached in memory until you are actually done backfilling it. And that's your best case scenario. And then number 2, one other important thing is query design, or how you use queries with Timescale. Just like Postgres, adding indexes to fields that are used in filters or group by in your queries, that will help improve query performance. So if you have a lot of query patterns that use a certain column, you'll want to also create an index on that column. But typically what I tell customers is don't necessarily create the index until you need it or you know that your query patterns use it a lot. Because remember, the trade-off to indexes is they do take storage space that you will have to pay for. So keep that in mind as well. And then another important thing for query design within Timescale is where you can implement time constraints in your queries. That will take advantage of chunk exclusion. And one of the great things about Timescale is if you implement time constraints and can constrain that time that you query data, it will actually not go look at every other chunk within the hypertable. It will keep it inclusive to only chunks that contain data that you're querying. And that helps pare down your data set and minimize the amount of data that it's actually trying to pull in and get a response from. So just keep that in mind as well. That is it for insider info on implementation. And we hope you like this 4-part series. We'll do it again on some other subjects, and we'll see you there as well. Thank you.